Hello, everyone. Welcome to all of you to the Business Analytics course with R, the first module. I'm Bharat. I'm going to be your instructor for today and for the rest of the sessions for this course on mastering data analytics with R. I'm physically based out of Bangalore. I have close to 11 years of work experience, 8 years of which has been as a part of the analytics industry. I currently work as a data scientist at Hewlett Packard and doing analytics on sensor data, or more specifically doing analytics on streaming data are my areas of interest. So that's a very quick introduction about myself. I would request all of you to provide your respective introductions too, and the way I would require all of you to provide introductions is by typing out your name, your place, your experience, and the expectations from this course in the questions box. So I'll state it again. Your name, your place, your experience, and the expectations from a program like this. Just a very quick note, that should suffice. The idea here is that it will give me some sense on the level of understanding across all the participants in this program. As far as business analytics and use of R in doing business analytics is concerned. So that will give me some flavor on how I could temper this program as we go along. So a quick note in the questions box introducing yourself, and then we will get started. Okay, I have responses from Aman, from Vivek, and from Joyce and Joydeep, and from Vishal as well. Thanks to all of you for typing out your introductions. So the sense I get is that most of you have been in the analytics industry for a fairly decent period of time, and you have had some good experience working with SaaS. You expect to become somewhat hands-on in using R to doing the analytics work that you've already been familiar with working in the SaaS environment, and would also want to learn some new age machine learning techniques using R. So thanks to all of you for your introductions. So we will begin with me setting some rules on how we would go on with the course. More importantly, if you folks have any questions during the course of this program, you could type it in the questions box just the way you did right now in providing your introductions. Provide me the questions as and when it arises, and I will address them if they are relevant to the topic on hand, just so my continuity in presentation doesn't get broken. But if it's somewhat different or distant from the topic on hand, we will park them towards the end of the class, or you could even reach out to me or email or give me a call after the class is done, and I could address it then. We will also take breaks during each session. So we know it's a 2-hour session each day. So we'll take a 5-minute break at the end of an hour. So that's about the breaks. You would also be presented with surveys at the end of each class. So I would encourage you to provide these surveys every day so that it gives me a good tab on how well you folks are keeping pace with my presentation, and if I need to change my presentation to a presentation style to meet your requirements, we could do that instead of waiting till the end of the program itself. So please provide your feedbacks to the survey questions that will pop up towards the end of the class. Okay, so we will start today's session by me providing you a quick view of what we call as the learning management system before we get into the content of our class today. So I would request all of you to log on to edureka.co, get on to your course page. The course page is the one for mastering data analytics with R. So if you have logged in here the way I am logged in to it as well under my login, so you would notice that the LMS, or the learning management system as is otherwise it's called, would look like this. So below this section here on the course title, you will see 3 tabs: Getting Started, Pre-recorded Classes, and Course Content. Within pre-recorded classes, you will find recordings and presentations from a previous batch of the same class. So you could hear through the recordings and also view the presentations. But for our current class, all the material pertaining to it, you will find it in the course content tab. So the structure within the course content tab is that you will have all of the modules listed one below the other. So this will give you a good sense of the curriculum for this program. Within each of these modules, you will see the presentation, which we shall use as the driver or as the core content for our class for that day. You would also observe assignments and solutions to assignments below these presentations, and also some further reading material and pre-work for the subsequent class. You would also notice that recordings of my presentation each day will also become available soon after the class is done, or more precisely, you would see them within 8 hours of the completion of the class. So if you would want to revisit the presentations, but also listen to me speaking, you will find the recordings right below the presentation slides. Okay, so even if you have missed these classes, you can always get back to it and listen to me presenting the classes. So that's one good feature about the learning management system here. And if you have questions during the course of the class, as I told you, you can always ping those questions to me on the questions box. Another option you have is to scroll up to the top right-hand corner of the learning management system here. Click on the support button, like so, and then pick the course to which your question pertains. And if it's a generic question not pertaining to any particular course, you could select the Edureka community option here. Okay, so say I select mastering data analytics with R, like so. Then you could choose the category to which you think the question pertains. So if it is in relation to a lecture I've made, or a general question, or a question that relates to a project or an assignment, you could choose the relevant subcategory and type out your question in here, and then we could it'll get addressed. So there'll be support agents at Edureka who will address this to you, and if it happens to be a subject related question, it would get directed to me, and I will answer them for you. Okay, so these are the various ways in which you can interact with the teacher and also with the Edureka platform overall. Okay, right. Now let's get started with today's module. If you have any questions um, now or whenever at any point in time during the course of our session, please feel free to type them out in the questions box. And as I said, I will address them if they are relevant to the topic on hand, or we will keep it towards the end of the course or to the end of the session, as the case may be. Okay. Right. So some of these topics here on slide 1 have already been covered. We all know it's a live online class. You're free to ask questions when you want. Please provide your survey feedback, as I mentioned before. And the support that Edureka offers is 24/7. So rest assured that your questions will get addressed. Class recordings are available on the LMS, as I mentioned before. There are module-wise assessments in the sense there will be questions or quizzes over the course of each session, which will try to reinforce your learning in each of these sessions. There'll also be project work at the end of the program, on completion of which all of you will be awarded a verifiable certificate, which you can display as a part of your LinkedIn profile. So these are things that we know. So getting more deeper into or speaking about the overview of the course itself, this is a 12 module program of 2 hours each. The topic for today will be an introduction to data analytics. So it's not going to be a very hands-on class for today, but I promise that from the second module onwards and right till the 12th module, it's going to be fairly or extensively hands-on rather. Module 3 and Module 4 are about how do we manipulate data in R, how do we import data in R. Then over 5 and 6, we will understand how to perform exploratory data analysis in R and also visualize data in R, which will help us communicate the underlying story in a very effective manner to the businesses and to your clients you work with in your organizations. The second half of the program would be centered around data mining and machine learning techniques. We will discuss some of the very popular and widely prevalent techniques like clustering or association rule mining. From a machine learning standpoint, we will discuss linear and logistic regression in some detail. We will also have discussions around analysis of variance or ANOVA. And we would also understand decision trees and random forests in fair bit of detail. There would be a project that would be the focus in module 12. So soon after all of this is done, you will be awarded a certificate which you can present on your LinkedIn profiles. Okay, so getting more specific to the objectives of our class today, the idea is to understand what is business analytics. So stepping back a bit, the title of our course, as you know, is Mastering Data Analytics with R. So it behooves us to explain what business analytics is, or what analytics is in general, which is the first part of this title, and then explain what is R, and what is its ecosystem, and what is the R community like. So those are the things which we would discuss. In some ways clinically examining that title itself. And after that, we will develop some understanding about what's the R language like, how is it, given that it's open source, how will users of the R programming language get support to the questions or concerns they might have in working with the programming language. We will also understand how R is being used in the industry, and I shall also bring in some flavor of how I use R in my role as a data scientist at HP. So that's something we shall examine. We will also compare R with other competitive analytical options that we have, more popularly the SAS programming language as the other alternative to R. So we will compare R vis-a-vis SAS. We will also perform some very basic operations in R using the command line. That's for today, but we'll get more deeper as we go by. We'll do this using the integrated development environment, R Studio. We'll also introduce you to a few GUI platforms on R, like R Commander and Rattle. And we will also help you come up to speed on how you could get some help from R itself and from the broader community on certain questions that you might have in working with the R program. Okay, so let's get started. The idea is to motivate the concept of business analytics using a few use cases. So before we discuss some of these use cases, I would like to bring up a handout which I will share with you in a while. So this is a handout which will help us understand the concept of business analytics better. And this is important because business analytics is often used interchangeably with business intelligence. So it's important to understand this concept first. So I will begin with describing what I call, or what is called widely as the knowledge hierarchy. And here we will discuss concepts like data, information, and knowledge. And when I say the word data, what it really suggests that it is unrefined and factual. So think of it from this example. where I say company X sold a laptop to a customer A for $1,000. So this piece of information really doesn't mean much to us, correct? Because it's devoid of content, in the sense devoid of context, or it is not qualified, right? So it really doesn't have much value standalone. But if you were to aggregate such diverse pieces of data across several quote unquote transactions, if you will, all of this becomes information, and this will have a meaning that it conveys. So if I were to say the total revenues for X Incorporation from the sale of notebooks in quarter 1 is 200 million. So this is a lot more contextual, lot more qualified, and lot more meaningful than the previous example I cited in the context of data, right? So information is basically several pieces of data aggregated and presented in a meaningful manner. So it answers the quote unquote what question that one might have. What happened? What happened was notebooks were sold in quarter 1, yielding 200 million US dollars for the company, right? But what is knowledge then? So if this information uh, from multiple sources were to be collapsed, or were to be brought together, then it would become amenable for analytics being performed on it, or also to the user to bring in his or her experience, overlay it on all of this information aggregated from multiple sources, and then come to some kind of an informed conclusion, right? So if we say that the total revenue from the sale of notebooks has seen a 10% fall because of a 12% fall in traffic to the store, then how is this possible for me to say both of these things together? Because on one side, I had transaction data coming in from all the orders that I processed, and on the other side, I had browsing behavior data coming in from all of the users browsing my homepage and then placing an order there. So I was in a position to bring both these sources of information centrally, and then rationalize why did the sales of notebooks in the quarter in question decline over the previous quarter, and we then say it is because of the fall in traffic. Right? So this answers the why and how question. So you would notice we have graduated from moving from data to information and then to knowledge, and this is what is called the knowledge hierarchy. Right? So one might have the question: how is knowledge hierarchy now relevant in the topic of business analytics and business intelligence? So that leads us to the next slide, um, which is actually the knowledge hierarchy in operation in an organization. So in an organization, you would also see data getting transformed into information and then into knowledge. So take the case of an organization transacting or interacting with all of its customers, its partners, and its suppliers, and so on, and entering into transactions with them. So a lot of these individual bits of transactions is essentially data, and they get collated in individual subsystems or databases, which forms the information world that we spoke of on the previous slide. So all of this information from multiple subsystems or sources then gets aggregated through an extract, transform, and loading process into a centralized data warehouse, which is usually called the enterprise data warehouse, which stands for the one-stop shop for all sources of truth in an organization. So here, once all the information from all of these diverse sources becomes available, business users can then query this database to get the answers they want. They could do reporting out of this database. They could even perform analytics on this database and try to rationalize not just why things happened the way they did, but also be predictive of how things would pan out into the future. Right. So this portion of the business intelligence cycle, on where one gets more smarter about working with data, gets more predictive, and looks into the future, is essentially the business analytics component of the business intelligence life cycle. So this distinction will make it clear that business analytics is in some ways a subset of the entire business intelligence framework. So business intelligence is something broad. It comprises of all technology, of all processes, and all infrastructure which help in transforming data into knowledge. And business analytics has a greater focus in the information to knowledge transformation portion of the entire life cycle. Okay, so now that we understand business intelligence and business analytics in conceptual detail, we could consider a few use cases. You could begin with considering a few use cases like so on the Edureka material. The first use case here is trying to use credit scores to predict the filing of auto insurance claims. So one might have this question, why at all would credit scores of an individual be used to predict claims for auto insurance, right? So how is it that that an accident that one enters into be in any way related to their credit history? Apparently, there are few research studies conducted by the Federal Trade Commission in the United States. They have shown that if an individual has failed repaying a loan, EMI, or has missed an installment on a credit card, there appears to be somewhat of a correlation with these facts with their increased risk of an accident on road. Maybe their failure to pay a loan EMI or a credit card installment might be suggestive of not a very disciplined lifestyle, and maybe that shows in some ways in their behavior on road. Okay. So one could develop a statistical model which could formulate a relationship between the credit scores of these individuals, which one might source from third-party credit scoring organizations, and combine that with demographic information or other information available to the auto insurer, and then be in a position to predict whether this individual is going to claim or is going to file a claim for an auto um, accident, right? So if there is a new policy that needs to be issued, we could plug in all of these values, demographic values or credit scores sourced from third-party credit scoring organizations into our quote-unquote equation, and then evaluate the premium that needs to be quoted to the individual in question. But if a policy has already been issued, then when it comes up for renewal, we might be more smarter about the premium that we might quote. So the idea here is that we can build a statistical model which will help us control the risk associated with our uh, with the insurance claims that we have issued out to our customers. Okay. Let me move on, and before that, let me check for any questions. No questions yet, but yeah, okay. There's one question here wherein Vishal asks me if there is any information that I could share about auto insurers out there in the US who are actually doing something like this. So I have a link, Vishal, which I will share with you. And I've pinged it to you here on the questions box. And all of you can see my ping. So please click on the link, and maybe towards the end of the course, when you have some time to spare, you can browse through the link and get to know more about auto insurers who determine their insurance premiums in so much more objective a fashion. So not just to this use case, but to each of the other use cases as well. I have a few links which will help you go in a little bit more deeper and understand how analytics is actually being used in practice. So that's another handout file I will share with you towards the end of the session today. Okay, so let's move on. And thanks, Vishal. I hope your question is answered. If not, let me know. Okay. The other use case that I'm sharing here is a use case which finds relevance in the medical industry in the United States, or for medical industries in general, because I'm going to speak about a US example, but it should be true to the medical industry in general. So apparently, there are 70 million people who are admitted to hospitals in the US each year on an average. And the US government incurs about 750 billion US dollars in hospitalization costs. And it's believed that of the 750 billion, almost 30 billion US dollars is preventable or avoidable. Or rather, this amount of 30 billion US dollars is essentially a burden on the exchequer. So one would have this question: how at all can you consider hospitalization as preventable or avoidable? The argument here is that if you are in a position to ascertain that an individual's health condition is worsening, maybe there could be an intervention mechanism wherein you end up calling the individual concerned or dropping him an email, advising him to visit an outpatient facility, yeah, and get him diagnosed by the doctor or get him evaluated by the doctor. And maybe such outpatient treatments or medications could have avoided the situation going offhand and eventually ending up in a hospitalization scenario. So that's what it is really meant by avoidable or preventable hospitalization here. So there could be statistical models that we could build, which will consider the current health or the last known health condition of the individual in question, combine that with demographic information and other claims that they might have filed recently, piece all of these things together, and then be in a position to determine when would an intervention like the way I just described can be undertaken, and advising the customer to reach out to an outpatient facility in time. So if there are such interventions that could be implemented, it could result in a savings of almost 30 billion US dollars a year to the US government. So this is another use case which uses predictive intelligence along with the one on the insurance premium I spoke on the previous slide. And all of this could be done with R. In fact, it could be done with any predictive or any statistical software like R or SAS or SPSS for that matter. But the focus of our course being use of R in doing business analytics, we will look at how we could do things of these varieties using the R programming language. Okay. The third use case here is about how a bank can consolidate all of its information from the various divisions and from its various branches, whether it be a home loan branch or an auto loan branch or its retail banking operations, to give one consolidated 360-degree view of a customer across all of these divisions. So this will give you a bird's eye view, or rather this would give a bird's eye view to the bank's management of all that is due by the customer to the bank in question and vice versa. So this is more of a data management use case wherein R could also play a role. But from my experience, I have mostly seen R being used from a classification or a predictive modeling standpoint. So those are more relevant and often witnessed use cases or applications of R in the world out there. Okay, let's move on. Okay, so this slide is about what business analytics is, the definition and who creates it and how. So we have seen this already in the first handout that I showed when we started our session today. We spoke about the knowledge hierarchy. We understood the concepts of data, information, and knowledge. We also looked at the business intelligence life cycle and business analytics being biased greater towards the later half of the cycle, the business intelligence life cycle, when information gets transformed into knowledge. So we are already familiar with the business analytics concept. So I shall move on unless you folks have any specific questions. So please feel free to type them out in the questions box, as I've mentioned before. Okay. Okay, so we will dwell a little bit more deeper on what are the components of business analytics, and it's popularly recognized to comprise of these components: statistical analysis, data exploration, or otherwise also called exploratory data analysis, data mining, predictive modeling, or also otherwise called machine learning, and data visualization. So some of these terms are fairly self-explanatory, and we will also look at them in some detail as we proceed through this program. But I would like to talk a little bit more in detail about data mining and predictive modeling, because these are terms which are often confused in the industry, particularly the difference between data mining and machine learning. The key difference is that while data mining suggests of discovery as the key element to it, predictive modeling and or machine learning um, presuppose a learning element in it. And when I say discovery in the context of data mining, what I mean is that it involves understanding the inherent or the underlying structure in a data set without using or without relying on any response or a predictor variable. So I've just brought in a new term called like a response or a predictor variable. And what I really mean by that is that if you have a uh, set of pieces of information which you would want to use to predict another phenomena, that other phenomena is called the predictor variable, and all that you use to predict that is called the the independent variables, right? So if you don't if you're not operating in a world wherein you have a response or a predicted variable, and you're only trying to understand the structure or the patterns in a database, this is called unsupervised modeling as well, with popular techniques like clustering or A rules mining, or also otherwise called association rule mining, and pattern recognition as a broad class of algorithms which are used here. So data mining is essentially unsupervised discovery of underlying patterns. But when we speak of predictive modeling or machine learning, this is mostly supervised, but there could also be some unsupervised elements, which is often used as a pre-processing step, right? But the crux of it, the crux of machine learning is primarily suggests or primarily lies in supervised learning. And you will find techniques like logistic or linear regression, decision trees, random forests, and support vector machines, and so on. So all of these are a part of the machine learning or the predictive modeling universe. Okay, we will we will look at linear regression, logistic regression, decision trees, and random forests in more detail as a part of this course. So that will be the machine learning world, which we shall examine in some detail in this program. We will also look at clustering, association rule mining, as well as a part of our introduction to data mining techniques as a part of this program. Okay, so let's move on the definitions of or understanding of statistical analysis, data exploration, and data visualization. Those would become very clear as we proceed during the course. Right. So if you have any questions on what they would really mean, you can, and if you beyond just the English meaning that all of us would know of these, please feel free to drop a note in the questions box, and I'll be glad to address them. Okay. So now that we understand um, the business analytics as a concept and all of the different components of it, we will now move on to understanding what's R, right? And so you'll understand the R programming language, its community, and its entire ecosystem in some detail. Okay. Okay. So I see a question from Joyce. Joyce asks if I could speak a little bit more about statistical analysis as one of the components. within business analytics. So there are a whole lot of statistical analysis that you could do in R. So it's in that sense, it's not a very easy term to define, but all that I can say is that the potential or the possibility of doing a wide variety of statistical analysis in R is really very immense. So it could extend on one end of the continuum from doing very elementary summarizations of your data set, from computing some standards of central tendency like mean, median, or mode, or dispersion like standard deviation of your data set, and going further and further in complexity, in fitting distributions, and doing several different kind of statistically intensive analysis, say doing ANOVA or doing any of these um, data mining or machine learning techniques which have an underlying statistical theory to them, right? So there are a whole lot of statistical based techniques, if I could say that, if you could put it that way, that you could do using the R programming language, and which is also essentially a part of business analytics as a concept, right? So that's really what statistical analysis as a component of business analytics really means. Okay, hope that answered your question, Joyce. Okay, thank you. So let's move on. So as I promised, we shall now look at what is R as a programming language and as a tool to do business analytics. One, R is a data analysis software. Okay, and before we explain or before we expound on what that really means, you are already introduced to the business analytics concept and how is it different from business intelligence. And we already saw that analytics will comprise of statistical analysis, exploratory data analysis, visualization, data mining, machine learning, and so on. So it's basically all of these that you could do using R, which will make R a data analysis software. Right? So it's as simple or straightforward as that. So you could do interesting plots as well using R, like what's featured on the screen here. Okay. Two, R is a programming language. So you could write your code on the console in R. So you could also create your own user-defined functions. So if there are certain steps in your code which you would want to reuse, then you can put them into a function and then call that function whenever you would want to reuse it, right? So you could do all of that in R, and that's what makes it a programming language. And more specifically, R is, as a programming language, is also defined as an open source implementation of another programming language. That other programming language is called S programming language. So we will look at that in some detail as we also examine the history of R and how it all evolved to the stage it is in today. And we'll look at that in a slide or two from now. Okay, so the image that's shown on the screen here is basically the R console, and you write your code. The code here is what appears in red font, and you write your code after the greater than prompt, right? And this is how it looks. So we'll do a very simple interaction with the R console today using our Studio integrated development environment. And you'll see that you could do some of these coding work on that console. Okay, so more on this in a while. And then R is an environment for statistical analysis. We've already seen this. The limit to the statistical analysis that you could perform in R is totally limitless. From the very basic statistical analysis you can do, from drawing up a histogram or distributions or calculating measures of central tendency or skewness. You could do a whole lot with R. You could do several statistical plots which will help you understand the data set in question, box plots, scatter plots, 3D plots, and the list goes on. So it's nearly endless, right? So all of these statistical analysis and their visualizations is what you can accomplish using R. So this also makes R a statistical analysis software. Okay, and then very importantly, R is open source. And when I say open source, what I really mean is R is free. And what does free mean is an important question. It's not as straightforward as it seems, because the word free is not to be understood as in free beer, but it needs to be understood as freedom. And there are 4 dimensions to this freedom characteristic of R. And those dimensions are: you are free to use R for any purpose. What that really means is that, say, Vishal here can use R to do churn prediction for a telecommunications industry. And then, say, Joyce can use R for, say, preventive maintenance, so predicting when a machine will fail based on the history of the machine's performance and so on. So basically the use cases in which you can deploy R2 can be many, and there are no limitations on which you can actually apply it to, right? So that is freedom for using it for any purpose. And then you also have the freedom to study how it works. So the source code of R is available to one and all to examine. So you can look into the internals of the R program and to try to understand how it works. So that freedom is available too. And then you also have the freedom to redistribute it. So what that really means is that if you had downloaded the exe of R from the comprehensive R archive network, so you have the exe with you, so you can pass on the exe to any of your friends or your colleagues, and you wouldn't be committing a copyright violation with that, right? So you're free to redistribute, and you're also free to modify it and redistribute. So no one prevents you from meddling with the source code and creating a new software altogether and redistributing it to people who might be interested in it. So that's the 4th freedom that a free software brings. So a free software should be understood in terms of these 4 dimensions of freedom. Okay, right. So let's move on. Okay. So one of the questions that Joydeep asks me is that, what do I do if I have issues working with R, given that it is free or an open source software and I haven't paid money to purchase the exe? Who can help me out if I have any questions or have any trouble installing it or working with it? So this is a question which leads us very nicely into this slide here. And this slide is about the community of users of R that's available in the world out there, which more often makes up for the non-availability of commercial support for R, right? So you can reach out to several folks and users in several communities, whether it be inside R or R bloggers or Stack Overflow and so on. And you will find users like yourself who might have answers to the questions you have. And what makes them so willing to provide answers to you is that at some point in time, during their learning phase, there were other users who also did the same. So they are willing to give back to the community, which has helped them build their knowledge in R to that an extent, right? So this is a very active community that's available virtually in the virtual world. So you can reach out to them, post questions, and you are most likely going to receive a very well thought out answer, not just from one person, but from several other persons who would also, several other people who would also want to provide their respective ways of approaching that particular problem. So you're more likely going to get not just one answer, but more than one approaches to solving your problem. So that way, the user community makes up for the lack of commercial support. Okay, hope that answered your question, Joydeep. Okay, thank you. Right, so now let's move on. Okay, so this slide gives us presents as a timeline of the development of R. So it all started in 1977 in Bell Laboratories, where John Chambers and Richard Becker started the S programming language. S was implemented as an R programming language later in 1991 by Ross E. Haka and Robert Gentleman. And by 1995, it was registered as an open source software. And as of today, 2015, an R version of 3.2 is itself available. That will work on a 64 or a 32-bit platform. So this is a very quick view on the timeline in R's history. Okay. Okay. So coming to the comparison of R with another popular statistical package called SAS. Let's examine this. One, R is open source and free, so that's something that we already know. But SAS is fairly expensive, and you will have to pay a uh, highly priced license fee, either for each individual seat in your organization or for the entire package itself, if it's not a function of a per seat basis. But all said, it's fairly significantly expensive, whereas R is open source and free. So this is something which most of us know, and given that a number of you have had experience um, uh, working with SAS, you know this already, right? And then we know that support for R is basically through email lists on Google Groups or Yahoo Groups, or on Stack Overflow and other virtual communities out there. But SAS has a fairly well established support and extensive documentation. There are also enough books that the SAS institutes publish, which you can also refer in getting support for the SAS package you might have purchased. Okay. One of the limitations of R is that it works totally in memory. That is, if you need to work on a particular data set, all of that data would be taken into the main memory of your computer. And when I say main memory, I'm referring to the RAM in your PC. So the size of the data that you can handle is limited by your RAM capacity, and also limited by the calculations that you will have to do once you have taken the data set into your main memory. So in a way, the available memory on your system will act as a constraint on the size of the data set that you can process. But then this kind of limitation doesn't exist in SAS because it works off secondary memory, which is a disk-based memory. So you don't have such solid-state devices in place. But one way of getting around this problem of R is that you could also use R on the cloud. So if you folks are aware of Amazon Web Services, you can fire up an R, you can fire up a node and bring in and install R in there, and then the limitations of the main memory goes away because you're working on the cloud, and it's very likely that you can manage to get a larger main memory capacity from this system in the cloud. So working on the cloud could be one ways of overcoming this limitation of R. Okay. R has much better graphics, is one advantage, and you could generate beautiful plots using packages like ggplot2 or Lattice, which will help you create a publication level or publication worthy graphs. You could also do that using SAS, but not using base SAS, and those images are going to be uh, fairly elementary, and even if you would want to customize them, it's going to require more intensive programming skills than that's required using R. You can also create custom functions in R, and this is something I alluded to a while ago. So if there are functions that you use over and over again, you can put them into a function shell and call that function when there is a similar situation for using that function arising later on. You can also do that using SAS, but it's fairly coding intensive. You could do that using what's called as a macro, which some of you might have used in your work. Okay. R has also a GUI frontend like R Commander and Rattle. So in case you aren't interested in learning to code on the console in R, you can have R Commander or Rattle installed, and you could do many of the data mining and machine learning tasks using R Commander or Rattle. You can also do that using SAS. So SAS Enterprise Miner has features wherein you can do any of these data mining or machine learning tasks through a drag and drop mechanism. But then that again is going to be expensive because fundamentally SAS is a licensed software. Okay. I will share another document with all of you later on, which will present this difference between R and SAS in some greater detail. So encourage you to take a read. Okay, job trends. So as far as job trends are concerned, um, apparently Indeed.com says that the demand for R-based jobs has increased significantly in recent past, with accompanied by fall in SaaS-related jobs. And the very fact that most of you with SaaS experience have enrolled for this program is itself indicative of the fact that the demand for our programming skills is increasing in the industry. Okay, uh, so this is fairly widely known. Okay, so moving on, there are also various products, R-based products that are available in the industry. Some popular ones are like the R Studio and Revolution Analytics. These are basically organizations which offer R-based products. Speaking of R Studio, R Studio offers the R Studio integrated development environment. So this is an environment which will help you develop your R codes in that environment, and it has features like highlighting the syntaxes better and in different colored fonts. It will help you debug your code and is a more amenable front end to work with than the open source R itself that you would get from CRAN. So that is one product that R Studio offers. It also offers a product called Shiny, which will help you build very nice visualizations with the R engine in the backend, and you can have these visualizations show up on a browser front end. Okay. That's another product that RStudio offers. As far as Revolution R is concerned, one of the limitations about R that I didn't bring about in our discussion on the comparison between R and SAS is that R is essentially a single threaded software program. And what I mean by that is that it cannot run tasks parallelly. So it will have to, it runs tasks sequentially, and which often acts as a limitation, particularly when you're working with very large data sets, or say in a big data world, and you would want to parallelize your algorithm across several nodes. In such cases, R will also often act up as a problem in solving or in working with such large data sets. And what Revolution R provides is two sets of softwares called Revolution R Open and Revolution R Enterprise. Revolution R Open will provide multi-threaded processing, it will help you parallelize R's tasks across multiple cores, and then also provide support for a particular price. And they'll also offer a similar software, but which is more enterprise grade worthy, wherein some of these packages for running several algorithms is what Revolution R has rewritten in a manner that it could scale across wider nodes or distributed nodes, and also packages which are compatible on a Hadoop or Teradata framework, right? So these are products that Revolution Analytics offers, and these it offers for a price. And organizations interested in them, which recognize that they would need an enterprise scale worthy R, can buy Revolution R's enterprise version for a fee. Okay, so that's about these two well-known organizations and the product that they offer in the R ecosystem. Okay, speaking a little bit more about other players, interestingly, uh, although I presented the comparison between SAS and R as competitors, SAS also offers an integration to R. And so this lets users not just make use of the SAS's internal analytical engine to do whatever statistical analysis they're interested in, but also use the open source R as well, which is integrated into the SAS environment. So this is a very interesting development. And the SAS Institute, in fact, views R as an opportunity and not as a threat. Okay, right? And then, just like Revolution R, Oracle also offers an enterprise-grade R. So large organizations can purchase this distribution of Oracle Enterprise R Enterprise from Oracle, which is and the associated benefits of enterprise level support would also come by. Okay. Teradata. Speaking of Teradata offers what's called as in-database analytics, and what it really means is that the R program that you have developed can be integrated into a Teradata appliance. And what it really means is, say, if you have a Teradata appliance, right, and you had to do analytics with the data in the Teradata database, you don't really have to move the data from the Teradata server onto an separate R server, right? So that would incur the costs of moving information from one server to another, and all of that can be avoided because the R programming language is integrated into the Teradata database itself. So this is what is called as in-database analytics, and is the in thing in the analytics industry today. HP's Vertica software also has a similar in-database offering, wherein you can integrate R into Vertica. Okay. Right. Who uses R? So before we get into the industries which use R, let's take a 5-minute break, and we shall come back to go through the various functional domains and industries that use R, and we will end this class with a few elementary hands-on session today, and we shall do a more exhaustive or a more detailed hands-on session in the next class. In fact, all our classes starting from the second class and all the way up to the 12th session will all be extensively hands-on sessions. So let's come back in another 5 minutes. Okay. I see a few questions in the questions box. So Aman asks me if we will be discussing at some point in the course, if we will be discussing techniques like support vector machines. So the answer is, Aman, we don't have support vector machines as a part of this program. It's somewhat of an advanced topic. So we will cover it in other courses on Edureka, but not as a part of mastering data analytics with R. So mastering data analytics with R is going to is looked at as some kind of an introductory analytics program in using R to do analytics. But nevertheless, we are going to cover um, random forest, which is also a fairly evolved classification approach. And we will look at random forests in real good detail. But to answer your question, we don't have support vector machines as a part of this course. Okay. Did that answer your question? Okay, thank you. So let's move on. The point at which we left off was here. Who uses R? The users of R are many. Speaking of the domains in which R is extensively used, it could range from telecom to education and everything in between. And I wouldn't, if you were to ask me, I wouldn't list any particular domain because the R as a programming language and the statistical analysis that you could do with the R programming language is fairly agnostic to any industry as such. So wherever you have a problem that a data mining or a machine learning problem, you could use R. The only constraint that you will have to be worried about is that is about the size of the data and whether you would really want it to be parallelized and how much is the size and whether it will seriously act as a constraint given the resources you have uh, and the version of R or the type of the R program you're using. What I really mean by type of the R program is that are you using an open source R which CRAN offers or other variations of R which lets you use it in an enterprise level setting where you can scale it across multiple nodes. Right, in which case you might want to consider a Revolution R version, but those are really the things that you need to be worried about, but not so much about the industry to which R would be applicable. Right? Okay, so there are a few companies that are listed in here, and you could, out of curiosity, read through their specific applications of R for various requirements, and this will be interesting to know what these companies do using R. So it has companies, very large companies like Google as well listed here, to others like John Deere. So it's in fact very widespread use across businesses of all types and of all sizes. And you have a quick list of various corporate clients as well that employ R for doing analytics in their respective organizations. Okay. Teradata and its use of R in database analytics, that is something which we discussed a while ago. And in fact, it's not just Teradata, a whole lot of other organizations, including Vertica, use in database analytics powered by R. Okay. Okay, so use cases of R. So initially we spoke about business analytics use case, and this use case here also has the same idea, is the idea being to motivate the various different kinds of applications where R is used. And most of these use cases you would observe, or you will come to observe during the course of this program, is that we will actually do or execute or perform these use cases by hand as a part of one of these 12 modules. So this particular use case that's being spoken of here is a use case called market basket analysis, wherein you can, using what's called as association rule mining, you can identify which product usually goes with which other product by examining the several different baskets or orders that are placed with a retail store or an e-commerce store. And then the applications are many. You would have noticed while transacting on Flipkart or on Amazon, you would have noticed this particular list of other products which are recommended at the bottom of the product page. And these are products that other customers often bought along with the product in question that you're currently browsing. So this recommendation of other products that go along with the one in question is fed by a recommender engine, which in its heart has a market basket analysis driven by an association rule based algorithm which supports such information being presented to the user. Okay, so we shall examine or do a quick short project on association rule mining later in the class, later in this program. Okay. So this is one use case where you can use R. Another use case is churn prediction, and this is something I can speak out of my experience. As a part of my data scientist role at my employer, what I'm also engaged in is to predict churn for a telecommunications client of my employer. So using a whole lot of usage data that subscribers of that telecommunication client's subscriber base, the usage that these subscribers have demonstrated, whether it be the number of calls made or the amount of data that they browsed. So using all of this information and also their demographic profiles and the calls made to the call center and so on, we can be in a position to say when a subscriber is likely going to churn and what is the likelihood for churn. So this is something that me and my team are doing using R, and we are also integrating it in database into Vertica. So these are use cases which are actually done in practice, as I can say from my experience. And you also have a first-hand account of in-database analytics being done by me, and you can talk to people around, and you will see that in-database analytics using R in solving problems like this is quite in vogue. Okay. Right, and this is of course one of the questions that Joyce asks me is that can I use this to predict churn for a banking client I am working for? Of course, Joyce, you can really do that. As I said, this is not industry particular. It's essentially industry agnostic tool. So it only lets you do statistical analysis on any data you feed it, and that could be for any business that might be, right? But it's important is that all that you need to recognize is that although I'm saying it's industry agnostic, it's important to engage with a subject matter expert from the industry in question to build a model which is a lot more meaningful and marketable to the clients or to the business you're working with. So that's important too. But as I said, the use of the software as such is industry agnostic. Okay, let's move on. The other interesting use case here is an application of R by the Los Angeles Police Department to predict crime before it occurred. So apparently criminals, not just in Los Angeles, or criminals anywhere in general are very, their areas of operations are fairly local. So if you expect the intensity of crimes to have increased in a particular territory of late, there is a very high likelihood that crimes might recur in the same area in some time, given that criminals are fairly territorial. So what LAPD does is that based on such events, based on the nature of these events and based on the frequency of these events, they are in a position to smartly allocate their police workforce to specific areas and given that the availability of police officers is going to be a scarce resource, they would want to make the best use of these resources, the wisest use of these resources, so as to be in a position to control crime effectively. So this is another use of a predictive modeling technique using R, but in the context of policing. Okay. And then another interesting application in R, not so much analytics as such, is that you could say analyze the content of Obama's "Yes We Can" campaign speech, and then create a word cloud of the speech, identifying the frequency of words by their sizes, or visualizing the frequency of words by their font sizes. So this will give you some sense of the underlying thought process in the candidate's mind and in the president's mind, and help you understand what's he thinking, and what are his beliefs or value systems like, right? So that's something you can glean using a word cloud of his speech, or for any textual content for that matter. Okay. Okay. So what we are going to do now is that we are going to do some getting started exercises with R. So as far as the installation of R is concerned, what you need to do is that if you haven't installed R already, you'll have to go to CRAN, or which is basically an acronym for Comprehensive R Archive Network, right? Log in here, and you can download it for the operating system that you have on your PC. Right? And you can either download a 32-bit version or a 64-bit version based on the machine you have. In fact, I think I should rather say the exe that you would download has both the 32 and the 64-bit versions within it. So when it comes up for installation, you'll only have to choose that particular bit type that you are interested in. Okay, so you can download it from here. So look at the version of R we are currently in. It's 3.2.3, right? That's the latest version of R in work currently. Okay, so after you've installed R, what you would also have to do is to download the R Studio IDE from the R Studio page, rstudio.com page. So let's go in here. So you should download the RStudio IDE or desktop version from here. Okay. And you could look through other products that RStudio offers. One is the RStudio IDE itself, or which is very simply called RStudio, and then Shiny, which is a visualization product, as I was saying some time ago. And then you also have RStudio server versions. And speaking from experience, I could say RStudio server is basically a browser front end to your RStudio program. So here you don't have so let me just bring up RStudio and this would become clear. So here the RStudio application that I fired up right now is an application installed on my local PC. But if I were to be using RStudio server, so if the data I'm going to work with or I'm going to do analytics on is somewhere on a server that's physically located far away from my location, and if I need to do analytics on it, I would not want to download all of the data from that server onto my local PC. And the size of the data might be so much that my local PC would not be in a position to handle, given its limited resources, main memory resources. So I would want to have an RStudio server installed on the same machine where the data rests, and then I can log on to a browser front end to an RStudio installed on the server. So using the browser front end, I can write most of the codes that I would have otherwise written on my local RStudio installations, and it'll have a very similar front end like this application front end here. So it will have so the browser front end will also have a console section. It will have the environment and history section, like you see to my right, to the right hand corner, top right hand corner, and the bottom right hand corner you will have all of these tabs: files, plots, packages, help, and viewer, just like the way you have it on your local installations. So this does away with having to move data uh, over a network from physically disparate locations. Okay, now that's RStudio server. Okay, and then you similarly you have a Shiny Server Pro as well. Okay, so ensure you download the RStudio version as well, besides the CRAN, besides the exe from CRAN. Okay, and then once you have installed both of these, you'll just have to bring up your RStudio application, and that will talk to the open source R that you've downloaded from CRAN in the backend. So you don't really need to use the open source CRAN or specifically or explicitly call the open source CRAN installation. As far as you're calling the RStudio, you are doing fine. It will talk to the R program in the backend. Okay. So here you can install packages. Say you can provide the name of your package. Say I say uh, car as one of the packages, and it will give you uh, a list of it will give you a suggestion as you just saw, like so. And then you could also identify the repositories you would want to install from. So you can click on the link and identify what are all the repositories available, and then you can configure it. Right? And I already have car installed, so I am not going to install. I'm just telling you how you could do it. You could also do it by writing a code like so, like how I'm writing right now. Install dot packages, and within double quotes, remember you always need to use double quotes when you're calling the install.packages function, and just type car and enter, and it will talk to the repository in question and download the gz file from there and install it for you. Okay, and after I've installed it, if you need to activate that particular package, and you need to make it available for your session, for your coding session right now, you will have to use the library function. Type in R. Here you don't need to add double quotes to car. Um, so it will. So if a prompt comes back, it suggests that the package has been activated for your current coding session. Okay. Now let's get back to our material. So we spoke about downloading R, installing it, and then how about installing packages and updating them. So you could update packages as well. You could go to tools and you could check for package updates. So it will identify a whole lot of packages whose updated versions are available on CRAN. And you could check mark them to update them all, or if you're only interested in updating a particular package, you could just check mark that package. And then once you've check marked it, you can uh, press the install updates button, and your packages are all up to date, right? Okay. So this just walks you through the installation process. It's fairly straightforward. All that you need to keep in mind is that during the course of the installation, you will have to identify whether you need a 64-bit or a 32-bit R. So you need to choose that particular bit which aligns well with your operating system. Okay. Um, right. So you could also go so I told you you'll only have to use RIDE for your installation purposes, but you could also navigate to the open source package that you've downloaded from CRAN. Just go to R here, pick that particular installation. So I have in my machine installed both the 32-bit and the 64-bit as well. So there's no problem installing both. So I have it installed that way. And then you could select the repository here. Okay, so this repository will identify which class of repositories you would want R to point to. So there are multiple repositories, and when I say repository, it's basically a large collection of various packages. So the most popular repository and the repository with the largest number of packages is the CRAN repository. And you have a number of them from a biochemistry or a clinical trial standpoint, which starts with the bio world. So you also have another such another such repository of packages, which has packages which are very specific to the medical industry. So you could if you know that a particular package is available there, then you need to have this repository point to that particular, or the selection point to that particular repository, and you can download from there. Okay. What else? So set the CRAN mirror. And what this means is that if you need to update or download a package, the copies of all of these packages are available in servers that are located in various places in the world. Okay. And you could also you could choose a location in India or anywhere in Southeast Asia or in the larger Asian world, and then you could download your packages from there, and the downloads then would work faster. So if you need to look for India, then you can just scroll down this list and you will see it here. India just has one mirror, and whereas say China has 4 mirrors, so you could choose anyone from there. I think you can also choose from Singapore, which might be the next nearest location to India, right? Select this CRAN mirror, and then whenever you update or download packages, you would actually be downloading those packages from these mirrors, right? Okay. What next? So we have seen this. So this says CRAN contains all packages. It's a repository of all packages. For other packages, you might have to visit other repositories, but mostly you'll do with CRAN. You'll do good with CRAN, and this is how you install a package. You could also add double quotes when you use a library function, but there is no harm if you don't use double quotes. That's something to know. And then this gives you the procedure for installing ggplot2 package, which is a wonderful package for drawing up or for plotting wonderful visualizations. Okay, so you can install it like so, and then activate it using the library function. So once you have installed R, you could do a whole lot of things with it. Things as simple as running a few calculations. Okay, so let's do something very elementary. Let's do a 2 plus 4. See, you get a result printed on the screen. So you can use it as a calculator as well, right? So, and you have a whole lot of other examples. So you can take a log, you can take an exponent, an exponential of any number, square roots, or any mathematical operations you can do right there on the screen, on the console, and get the result immediately. Okay. And then you can, so let's keep R Studio aside for now and look at the basic CRAN package, the open source R that you've installed. You could also you develop the scripts using the script editor, and what the script editor does is that if you are to be using the console as is, if you hit an enter, the set of codes or the functions that you have typed will begin execution. But you also have the option of developing the entire script here in the script window. And once you have developed the entire script, you can copy all of the script and paste them onto the R console, and for that to execute as a group instead of executing it one statement at a time. So this is essentially the where you can do all the scripting, but this is seldom used in practice. Folks like me or generally data scientists using R would write these codes using R Studio console, or they will have use the coding environment here, right? And so right above the console section, you have this environment where you can type in all the codes and you can execute them in groups later on the console window. So most of the development work happens in our studio because it has better syntax highlighting and better debugging features than using the open source R, than just using the pure play open source R from CRAN. Okay, so I don't do any scripting work on R CRAN, but I'll do it on the R Studio IDE itself. Okay, yeah. Right. So this depiction here, you have written all of this code on the editor. You copy all of this, paste it onto the R console here, and you get the result. So if you wouldn't want a line of if you want to comment the code and you wouldn't want it executed, you will need to add a hash symbol up front. So that line of those line of words will be ignored. So you could, if you are, it's a best practice to add comments to your code and to make them more descriptive and for a newer person to know what you have written. But the writing of these comments should also not prevent you from taking entire blocks of code and executing them in one go. So use a hash in such cases. Okay. So there are a whole lot of packages available, and the last time I checked, there were about 6,000 packages that the CRAN repository has. Maybe there are more. So you can browse through the CRAN's website to see how many packages that are available as of today. So the number of things that you can do with R, given so many packages available, is almost limitless. Okay. And we spoke about downloading RStudio as well. So you could download that file which is suited to your operating system. So we also looked at the RStudio environment. You had a development environment at the top, a console at the bottom, a workspace location in your top right-hand corner, and another section at the bottom wherein you can navigate to the files or the packages in question, or your plots will also be will be visualized in this section. Okay. And okay, so now say you are working on the RStudio IDE, and you have certain questions, or you know a particular, say you know a particular function that you might want to use, but you would need to know more details around that function on, say, what argument to call within that function, right? Say, and I need to fit a linear model or a linear regression for the data set I have, for which I need to use the LM function. I know that LM exists, but I need to know more about the properties of LM and the arguments that are used in there. In such cases, I would just use question mark LM. And so here in the help section of the RStudio IDE, you will have a page that comes up which will give you a lot more information about the LM function and the arguments that you could use with it. Right. So you could also accomplish the same objective using the help function. So just say I just type help of LM, and that will lead you to the same page. Okay. Say if you don't know what function to use, but you have some vague idea of uh, what you would want to do. Say you would want to do linear regression. So I'll add 2 question marks and just say linear regression. And hit an enter, or maybe I should have used just without the spaces. So what this would do is that it would search the regression word that you have typed. It would treat it as a keyword and search that keyword in the entire CRAN repository and would give you a list of functions that you can run, right? So you can pick that function which you are actually after. If scrolling through this list jogs your memory and you're in a position to identify which particular function you are really interested in. So you could add double question marks if you're not sure about the function's name, but you have some vague idea about it. Okay, so you'll have a whole lot of search results that show up this way. Okay, so that's the use of the single question mark or the double question mark. Okay. So as a pre-work for this class, I believe that you had to set up R on your systems and also install the foreign package. You could do that now if you haven't done that already. So I would give you some time, maybe towards the end of this class, for you to try out these installations, and you can ping me on the questions box if you have any concerns on or any questions on how the installation is going, and I'll be available to help you all. Okay. We have an assignment as well, which you would have to do soon after you have finished installing our CRAN and then our Studio. Please install these packages PLYR, ggplot, and R color brewer, and you can create a program to input certain values into certain R objects, and then do some elementary calculations like average and then printing the result of that average. We will go over your experiences in doing this in our next class. That's tomorrow, and you could let me know if you have been in a position to complete installing these and finish writing the program. Okay, so in our next class, which is going to be a lot more hands-on than the class today, we shall put an effort to understand what are the various data types in R. And this is a very important class for all of you to attend and listen to. This is going to form the basic building block of all your R coding exercise hereafter. So we will understand how data is stored in R. I will introduce you to some data objects like vectors, whether it be numerical vectors or character vectors or logical vectors. You'll understand what a data frame is, what matrices are, what lists are, and what arrays are. Ultimately, all information in R will be stored in one or more of these object types. So that's something important. And we will also explore some inbuilt functions in R, like calculating the sum, what function would you use, calculating the mean, what functions would you use. If you need to create a summary of a data set, what function would you use? We would also go through some simple functions that you can create on your own, especially if those are tasks which you do over and over again. You can create functions of your own, which we call as a user-defined function. We will also consider that in the class tomorrow. And a number of these data munging tasks or data manipulation tasks will require subsetting of data in various ways and understanding the various data types in R, like vectors and arrays and data frames and matrices is very important, so that you will know how to subset data which is available in any of these formats in ways suited or in ways required for you for the analysis on hand. So we'll also get introduced to subsetting functions in R tomorrow. Okay, moving on. And as I mentioned at the start of this class, providing your feedback is very important. So after we are done with our session today, I'll continue to be, I think we have another 15 minutes to go. So I'll continue to stay online. I'll encourage you folks to take these 15 minutes to download all of those software exe files from the net, install them, and post questions to me on the questions box in case the installation doesn't go through fine, and I would be glad to help you. But once we are done with today's session, you would be requested to provide your feedback for the class today. Please feel free to provide feedback, and it's going to be very important to me to model my presentation style and the content accordingly. So please make it a point to spare a few minutes to finish the survey. Okay, so with this we are done. In case you have any questions right now, please let me know. I would be glad to take them. And remember, I'm around. I would encourage you folks to uh, download these files and finish up the installation process and let me know if you have any questions. Okay, and then bye-bye.